Please, are we okay? Okay, let's take this example here. I'm in the class. I'll call you after the desk. Hello. Okay, so let's take another example here. Use the Convergence series to estimate the value of. Have you done that question? There's a very important question here.
You said he didn't count. So you said he didn't count. We should have this.
This question is pregnant. These are just, we are finished with the floating of points. But you see, we are moving on to differentiation and integration. There's a question like this that dropped some years back. I want us to look at how to solve it before we move on to different dimensions. Is that okay? When you get the past question, try to solve it in your notebook so that when you are revising, you are not getting past question. No past question. Are you sure? I'll check my things and see. We sent them home, that is why. Because of the COVID-19. I hope I brought my book. I'll check it and see. Please, I hope you can remember that Convergence series. Can you remember them? Yes. The Taylor series leads to the Convergence series. True or correct? True. Yeah, the Taylor series. I remember in intro analysis. Is it intro analysis? Yes, intro. Now, why something is zero? We get Convergence series. Or why something is one? Get one or something. Zero. We get the Convergence series. Please, the Convergence series is very simple. It's very simple. It's given by how can I tell us? E power x is equal to 1 plus x squared over very good. S cubed over oh, okay, that is it.
It's called what?
The Convergence series. The Convergence series also. These are the names. So please, we are to estimate this one to at least 1.5 error. Do you know how this one means? It means that in each of the case, we must calculate the error that is being committed. We calculate the error. And how do we calculate the error? Here. That's the problem. So here, we don't take the question like that, then just be substituting our values here. No. We have to build a table in order for us to get our correct what? Error.
Is it also under 40 points?
It's under what we did, the errors that we did. Error question. This is type of an error question. They will not give you the one that we did, that small one. They just be quoting this, just use the Magloran. Here, you have to know this theory. You have to put this one in your head. So that when you get it, you can just be fixing your values. But this one will help us to get the values. Thank you. So let's see how we can go about it. So first of all, we need the number of terms that we have to start with. Number of terms. Then we come to 1.5. Are you doing this one in the class? Did you do this one? Yes. Then you go to the approximated error. Then you go to what? That is the percentage error. So doing that, I'll be getting some of the past questions and I'll be bringing them time by time so that we solve them. Okay, so please, you do the working somewhere, then you bring the values here. So when n is equal to 1, so in the first part, what do we do? So when here is the first term, the second term, the third term, and what? The fourth term. So here the n here is the number of terms. So when we have the first term, when n is equal to 1, what will be e to the power s? Is 1. This is clear. So when n is equal to 1, our e to the power s, that is e to the power 1.5. E to the power 1.5 is equal to 1. Please, are you okay?
No, no.
Please, under the Maclaurin series, no, we are saying that we are doing the number of terms. We want the term in which when we get to that place, when it gets to 1.5, I will tell you where it's getting to 1.5. But how do we do it? You see, the first term is under this series, you know, the first term is this one. The first one is the first term. This one is the second term. This one is called the third term, the fourth term, the fifth term. So the number that I will write here symbolizing the number of terms that you have to use. So if I write here 2, it means that you're going to use up to this point. Is that okay? Yes. If I write here 3, it means that the formula will be up to this point. The fourth term, it means that you have to this point. Is that okay? So that is it. So when we have n is equal to 1, that's the first term. Our e to the power 1.5 will be equal to what? The same one. Because the first term, you don't have any coefficient of s here whereby you will substitute the 1.5. Is that okay? This x here is what is it? So every number here, you substitute here to find the value of it. So f of 2 is equal to 2. Every constant is equal to a constant. So if I have a constant of a number, you get the same constant. But that's why integration, when you integrate the function, we get what? A certain constant. Is that clear? The reason why we have the constant is that it's called arbitrary constant, because when you are differentiating a function, when you differentiate a constant, maybe 1 million, 2 million, you get the same what? 0. So when you differentiate, for instance, differentiate 2x squared plus 6, it's the same what? 4x. If here is 200, you get the same 4x. So that's why we add a certain constant here. Means that this is an arbitrary constant. The number there, no, we can get series of numbers. So integration takes care of those constants. So we get the first one. So when n is equal to 2, so let's substitute there. When n is equal to 2, what are we going to get? So it means that this one. So we get e to the power 1.5, which is equal to 1 plus what? Which is equal to. Please don't go and put the 2 here. The 2 there, the n is just telling us the number of terms. Please, are you okay? This n here, the number that I'm going to write here is telling us the number of terms that we have to concentrate on. But that will not affect the answer here. So we are not substituting 2 here, but we are just substituting the 1.5 in place of what? The x. But it is telling us that the number of terms to use to calculate that 2 is what we are looking for. So don't let this 2 confuse you. We are just here, this one is just telling us the number of terms that we are just calculating. So you can see that here we can just write here, because we wrote it, we can write a 1.15, 1 plus 1.5, and we got 2.5. How do you calculate the error? Please, how do we calculate the error? The error here, when we calculated here, we got 1. Is that not 1? So the previous one here, so it's 2.5 minus the previous number that we get here. That is what? This is that clear? So 2.5 minus this will give us what? 1 point. How do we calculate the error percentage? You multiply by what? 100. So it's 1.5 over. To the number that we get divided by it, multiply by what? 100. And we are getting what? 70.
Then you go
Mm-hmm.
the second part again.
61. Okay.
The second part again.
The second part again.
No, where the error is.
Error. See, when we calculate here, we got 1.
How do you get the 1?
You see, the first one, when n is equal to 1, the first thing gave us 1.
Oh, okay.
Is that clear? So to calculate the error is the difference between what? The first and the what? The current one. So the difference between this and that. So you subtract this one from this. You get what? 1.5. Is that clear? So 1.5, to find the percentage error, we divide the 1.5 by the terms, then what we got here, no? We multiply by what? The 100. We got 60%.
The approximated error is the second one minus the first one.
Yes, please.
So that means that for the first end, since we don't have any current, we don't have any approximation.
Yes, please. If you don't have, you can say it's just 100%. You can even approximate it to 100% error. Exactly. That's the first step. But here it's not advisable. But what you do here, you can just put that here. If you write 100%, that's not concentration. We want to estimate it to at least 1.5 error. Are you okay? So please let's go to the 3. So when n is equal to 3, this 3 means that we are concentrating on what? The first 3 terms. So we choose this one. E to the power 1.5 is equal to 1 plus 1.5 plus 1.5 squared all over what? 2 factorial. So compute for it and just write the answer. Please here we don't approximate the decimal point. So whatever you get, you write the whole of the decimal points down. So what do we get? 3.62. Is that okay? You get 3.625. So please, you can just be writing this one here, but it will take all the table. Just arrange it for you to see. So you get 3.625. So what will be the approximated error? So it will be 3.625 minus what? And what are we getting? 1.125. So calculate the percentage error. So we got what? 31 points. Wait there, this one does not have any effect on the other one. So let's calculate when n is equal to 4 on the 4th term. So e to the power 1 point when n is equal to when n is equal to 4, e to the power 1.5 is equal to 1 plus now what are we getting? 4.1. So 4.1875. So 4.1875 minus 3.625. What do we get? 0.5625. So you convert that one to an error percentage. How about 5? Calculate the 5 and solve with the error. Okay. I don't know. Come to SR5. You French block also. That be French department. What is it? Which one do you get?
0.394
The decimal. This later. Here the error. What do you get for the expected error?
0.21 0.9375 0.9375.
Okay. So you can continue. Please, the error that you want to get now, the error percent should be something 1 point. It shouldn't be more than 1.5, but at least 1.5. Is that clear? Like something 1.5
or below.
So please, so under the 5, we are getting the percentage that we got here is what? Is it 4.75 something percent? You see, still we can do further again. So we continue. So we continue with the sixth one. Calculate the error and convert it to the error percentage, and let's see. What did you get? We have 1 point what?
1.41.
So now we can end here. Is that clear? So you conclude by saying that the estimated value of 1.5 to at least 1.5 error is equal to 1.42%. Then you write this as the answer. So please, you compute till. Is that clear? So if they ask you to use the masculine theory to find the right estimated error to at least 1.5 error, you see the percentage of committing this error is this. So when you get here, please, here is bigger. You see the figures are bigger, so we can't end here. You must go below. Is that clear? You must go below, but it shouldn't be too much. But when you are getting closer, you see this one number is getting closer to 1.5. So we pick this one as the percentage error here. Please, is that okay? So the calculator should work well. These things are calculator works. So you put in the calculator, then you change it. You put the calculator, then you change it. All these things are calculator works.
Then it's 1.5 error.
1 point.
1.5 error.
Yes, please.
That one will give you a hint where you should.
Yeah, that one will give you the hint to where you should go.
You get the value less than that of it.
And you see, you will not get exact value 1.5 then. Is that clear? But it mustn't be beyond that. Is that clear? You see, we got something quotient and estimate and the other thing. You see, we got some estimations. We don't, when you say quotient estimation, it means that it must be equal to 1.5. Is that clear? But you will not get exact, but at least it should be. You see, you can't take this one as the error here because 4.75 as compared to 1 point that. You see, it is too huge. The error margin is too huge. You are not getting to that place. So let's work again. So this side, we are seeing that this side is more closer to 1.5 than this. Please, are you okay? So if you continue again, we are likely to get 0 point something, in which we are not interested in getting that one. So it should be something that is what, but it shouldn't be more than that 1.5. There's something below or the same 1.5. Please, are you okay?
Okay.
Please, can we continue from this point? So we are bringing our discussions here to an end. We have continued from some integrations and differentiations and numerical analysis. So that we do some other things here then. This one, they are going to the nose well. Please, can I create the method? Or some people are so confusing. Okay.
So what do you do the conclusion? What do you do the conclusion?
The conclusion. So, with the estimated value of this, at least 1.5 error is please, can I continue with this? I want to claim the method.